Hello and welcome to the ARADEX HDFC tutorial. HDFC stands for High Dynamic Flux Control. HDFC is our new motor control for asynchronous motors. The HDFC motor controls combines highly dynamic movements and efficient operation. So in this tutorial I'm going through the configuration progress of an asynchronous motor step by step, and at the end get it running. So let's have a look at the device setup here. And first we have our vector power device. This is the tutorial device here, boxed. And we have here the power on switch, switch it on, the intermediate circuit, switch it on, hardware enable, switch it on. Now it's ready to run. And next we have here our asynchronous motor. That's a simple small motor running on 60 volts for demonstration purposes. And third we have our Windows laptop here. And this one is connected via a peak CAN adapter to the vector power. Okay, then let's start with the software. Start the vconfig program first. This is our configuration tool for all the vector power devices. Here we start at the welcome screen. Now let's search for the device. So here they are. I picked the one with the vector power icon here. So there are two entries, but the right one is with the vector power here. The other ones are general can open devices and connect it. In this program, the first step configuring a new device is always to start with the wizard by this button here. Then we have some configuration on the device now. I will reset the device to factory clean defaults, so we can do all the steps from the beginning. Go next. So this takes a little time. So the device is restarting, and after that it is at factory clean settings. Okay, here we are. First thing to do is choose the control mode, and because it's a motor, we choose simple speed mode and go to the next page. In this motor wizard screen, we need to type in all the motor parameters, and for this you need to have the motor datasheet at your hands. It's right here for me. And we start with the motor type. As we configure the HDFC mode, we choose asynchronous HDFC. Inward motor direction is an option to move the motor the opposite way, which is good for mine here. Pole pairs, I type now in all the parameters from the datasheet. I have 2 pole pairs and a raise speed of 100,000 APM. The max peak current and continuous current is all important to type in. It's good to have the peak current above the continuous current. For my motor I can use 32 amperes peak current, 18 amperes continuous current. For the peak time, as we do some measurement in this wizard, should pick some value at about 60 seconds. If you're motor can take it. If that is above the motor data, you can lower the default the value at after configuring process in the wizard. And here the speed limit is 50 Hertz for this motor. Next step, there are some other values to type in. If you are not have these values at your hands, then you can calculate them automatically. And we go to the next page. That is the temperature sensors. For my devices here, I don't have a temperature sensor wired, so we just skip this. On this next step, we need to set up the current control. For this, we have this automatic setup procedure here, starting by the Start Measurement button. The high voltage will power up now. Please pay attention to the safety instructions. And the measurement is running. Okay, now it's finished. The measurement got a value of 0.31 millihenry. And if you have the inductance of your motor at your hands, you can skip the measurement and type the value just in. After that, we can calculate the current control parameters automatically by this button here. Go on to the next page. We have the encoder type. For this model over here, we have a resolver. If you have a resolver, please choose a delay of about 200 or 200 and maybe 10 microseconds. We have a frequency of 10,000 Hertz and polar pairs of 2, a ratio of 0.28, that's correct, and a voltage of 7 volts. Going to the next page, there's a test function. If your wiring is correct, you can start it by this button here. I skipped this because we have a running test devices here that are correct. So the next thing is the HDFC parameters. For this we have two measurements here. First the starter resistance and the HDFC measurement itself. The starter resistance is needed for the following HDFC measurement. If you have the starter resistance by the datasheet of your motor, then it's best to type them in here. And we have two methods of measuring this value. If you don't have this value, there is a manually measurement, which is the best thing to do, and there's an automatic measurement. That is okay if you have this external volt measurement wired from your vector power to the motor, like in this graphics here below. But most of the vector powers do not have this, so this is maybe a measurement you can do in the first step, what we will do right now. But in the next step, I will show you how to do this manual measurement, and that is what we recommend to do. So, but for now, make it easy. Start with the automatic measurement. And again, the high voltage is ramped up and the starter resistance is measured. So we have measured the 60 milliohm right now. You can go to the next step, do the HDFC measurement. This is again starting the measurement with the Start Measurement button. The device will power up. Please pay attention to the safety instructions. All wires should be isolated and wired correctly. The motor will rotate at full speed in this measurement steps. please have it fixed so the motor cannot move. Let's start. And this measurement will take a little longer. It will take some minutes to finish. And at the second half of the measurement, it will rotate at full speed. Okay, the measurement is done. We can finish the HDFC. There are now some parameters to optimize the HDFC function, but for now it's okay to go with the defaults. Last step to do is the configuration of the speed control, and here I take some values. For example, I take 45 Hertz, that is the nominal 50 from the motor, minus 5 tolerance, and here maybe 30, 39, that's okay. And all the other parameters, the nominal value is at 7 Hertz per second. Deceleration also, that is okay. Car pace 1.2, TN is okay. So now these are the new values that we configured for the HDFC parameters. And I can finish now and go to speed mode. I have that here. Okay, now we are ready to turn the motor on. So we have a torque limit here that is 7, and the speed mode. Enable the motor, and let's start turning it. Start with 2 Hertz. Now the motor is running. Can speed it up, like 10. That is okay. Stop it again. So this was our first step of the HDFC function. The motor is now running. But as I said, there is the starter resistance value of the motor, and that is not very correct. And in the next step, I will show you how to measure this value manually, because it's much more precise. So now, after we successfully did our first run of the motor, we need to get back to the starter resistance measurement. This is because the starter resistance measurement included in the wizard isn't very precise, and depending on this value, the HDFC function doesn't work very well if that is different from the real value. So for this, I took off the motor plug here, and we need to measure the starter resistance of the motor manually. For this, I'm using now a constant current source that is put to 10 amperes output, and we wire this to the motor cable here. And important is that if you do this, you need to measure the starter resistance value at the very near of the vector power. So don't measure the starter resistance at the motor plugs, but use the cable additionally. So the resistance measure value that we measure is somewhere near some milliohms. That is very, very less. So it's important to measure the cable too. Okay, now I'm using here the 10 amperes output. I'm using the pins between two phases of the motor, and I have here a voltmeter, and I'm putting 10 ampere output between two phases and measuring the voltage that is on the pins now. And this is 0.546 about volts, and we have the resistance is voltage divided by the ampere, so that is 55.3 milliohms, and it's because the starter resistance between two phases, we need to divide this value by 2, and then we get 27.3 milliohms, and that is what we type in the motor starter resistance value now. Now, as we have our precise starter resistance value, we switch back to the wizard and repeat all these steps, starting from the starter resistance page down to the finish. Repeat that again. Start with starter resistance, go into the starter resistance field and type in the 27.3 milliohm value that we measured before. We go to the next screen and repeat again the HDFC measurement for this. Push the start measurement. Again, the motor will power up. Again, this will take some minutes. Again, please make sure the motor is freely running, all the wires are safe, and the motor will turn up to maximum speed. Make sure it's fixed properly and cannot do harm. So the measurement is finished now. We have a warning here, but that's okay. We have optimal measurement results. So the HDF is configured fully. All values are correct. These didn't change. Can go to finish. And now I have a motor parameters and HDFC, which should be very good now. Can test it again by start the motor running, enable the motor and give it some speed, 10 rounds per minute. Yeah, that's it. Now you have your HDFC running correctly. And we finish. Thank you. Goodbye.